Okay, class, today we're going to work on power calculations. So they're very similar to work calculations like we did yesterday. Remember, work is the applied force over a certain distance. Today, power is how much work is done in a certain amount of time. So we can say it's the rate at which work is done, or just how fast you do work. Okay, so the equation we're going to use is power equals work over time, or P equals W over T. Now, in some of the problems, we may be given the work, but we also might be given a force and a distance. And so that is this equation here, where we're going to have to calculate work first and then divide it by the time. As always, we've got those important units. And remember, joules is for work. Time we'll do in seconds. Our only new one is power, and power is in watts. Now, I like to think of this like a light bulb. When you turn on the power, the lights go on, and we measure our light bulbs in watts. So you might have a 60-watt bulb or a 120-watt bulb. Okay, so our power is in watts. So let's do a couple practice. So the first one, how much work is done if a power of 100 watts is used for 3 seconds? First question is always to ask, what are we looking for? So this one asks how much work is done. So we're going to have to rearrange for work. Work equals power times the time. We're going to write down our variables. In this one, we used 100 watts of power for 3 seconds. Finally, show our work. Now, just like yesterday, our units of watts and seconds don't cancel. And so we need to memorize that that work is in joules. So here we've got 300 joules as our answer. Remember, you guys, those units tell us what our measurement is, so what we're measuring. So units are extremely important. Okay, next problem, a little bit more difficult. It's asking how much power is used when a weightlifter lifts a barbell with a weight of 1,300 newtons, a distance of 1.5 meters in 4 seconds. So we know that power equals work over time, but unfortunately we're not given a work. Work would be in joules. We're given a force and a distance, and so we'll calculate the work first and then divide it by the time. So our force is 1,300 newtons for a distance of 1.5 meters, and it takes the weightlifter 4 seconds. So we'll do the top first. So to find work, we take 1,300 newtons times 1.5 meters, and then the rate we divide by 4 seconds. So 1,300 times 1.5 is 1,950. And when we divide that by 4, we get 487.5. And again, newtons, meters, and seconds don't cancel each other off. So we've got to memorize that power, our new unit, is in watts. This is going to be the hardest those problems will get. So if you're still following along, you're doing a great job. Okay, we've got one more practice problem similar to this one. A 400 Newton elevator goes up 20 meters in 5 seconds. How much power is used? Again, we notice that we're not given a work, nothing in joules. So we've got to find that first, and then we can divide it by the time. So our force, we've got a 400 Newton elevator going a distance of 20 meters, and it's taking 5 seconds. So we'll find our work for first and then divide it by how long it took. So when we take 400 times 20, we get 8,000. 8,000 divided by 5 is 1,600. And again, newtons, meters, and seconds don't cancel, so we have to know that our power is going to be in watts. Okay, you guys are ready to work on the power worksheet, which will be due next class period.